In this video, we're going to be looking at a Heathkit vacuum tube voltmeter model IM-5228. I just received it from an auction that I won on eBay, and we're going to take a look at it, preliminary look at it in this video, and then we'll look at it more in technical detail in the next video. And if that's something you're interested in, then stick around for the rest of this video and let's see what comes out of it. Hey, this is Wolf from SRT Amplification, and I was just here on the bench working on this Tektronix 2225 oscilloscope, and the mail lady came to the door and dropped off a package, something that I'd ordered here a while back on eBay, and I thought it'd be a good opportunity to shoot a video about it. And so I'm going to sit it on the bench and we'll talk about it a little bit. In this section, we're going to probably just take it apart and look at it, see what all the features it has and everything, and then in the next video we'll go into a little more depth as far as the technical aspects of it and what we're going to do to restore this thing. So let me get it on the bench and we'll look at it. Okay, so what we have here on the bench today is a something that a lot of people don't use anymore with the invention of digital multimeters and such. They've kind of gone by the wayside, but it's a vacuum tube voltmeter. And this particular one is made by Heathkit. It's a model IM-5228. And I got this off of eBay. I wanted to read you the letter that I got with it. If I can find it here. I'll just stick it up here on the screen and you can pause it if you want to, or I'll just read it aloud here. But this is what came with it. It says, "Thank you for your purchase. Every purchase helps me, a 16-year-old high school student, pay for college." I thought that was pretty cool. Every purchase is greatly appreciated. Please check out my store to see if there are any other great deals that you might be that might interest you. Thanks, high school flipper. So evidently this guy, I went and checked out his store, and he's got a lot of stuff in there. It's not just electronics and stuff. Basically anything he thinks he can sell. I guess he goes to garage sales and he's basically a picker, I guess you would call it. But he's got all kinds of stuff in there. A lot of CB radio and ham radio equipment and stuff like that. But I've been wanting one of these valve. So check out his store. I'll put a link in the description below to his store on eBay. And but I've been wanting one of these valve or vacuum tube voltmeters for a very long time. And I wanted to get a bench model. And not one of the portable handheld types, that you would like take off your bench and use someplace or whatever. But, and I found several, buy now, in the range of about, anywhere from $50 to $100, a lot of auctions that ended up going for, $70, $80, $90, $100 or even better. And I really didn't want to spend that much money on it. So, I found this one for $20, I guess it started out at $20. Nobody bid on it. And it's got some problems I can see. But we're going to go through this and look at it. Preliminary little video on this, and then we'll get into it more in depth. But basically, what these were used for was in lieu of a regular analog meter. And the reason being is, well, there's a lot of different reasons for having a vacuum tube voltmeter as opposed to just a regular analog meter like, your Simpson 220 or something like that. One of them is this is a lot higher impedance, input impedance, so you get a lot more accurate measurement. Whenever you have a higher impedance in parallel with what you're testing, then it makes the measurements a lot more accurate. Another thing is this thing being the input voltages and stuff being fed into tubes. you can over voltage this and not run too much current through the meter and mess up your meter. Now, you may over voltage the tube, but you can always change out the tube. But whereas in a regular analog meter, if you over voltage it, the current is going to go through the meter movement and burn up your meter, and you're going to have to replace the whole meter movement and everything in that. So that helps. And then there's a lot of other aspects of this. On the DC side, the probe usually has a 1 meg resistor in series, and that if you're working around radio equipment or something like that that's got high frequencies and stuff, that helps with the it creates a filter circuit, blocks out all those high frequencies on your DC. It also it also counteracts the capacitance of the meter, so that if you put it into like an oscillator circuit or something like that, you're not going to affect the resonant frequency of the oscillator circuit as much as you would if you didn't have it in there. So, but we'll get into all the technical aspects of that in another video. But I just wanted to tear this thing apart, and I'm going to be tearing it apart and looking at it same time as I'm making this video. So I can already see on the outside here, it's got a cracked meter face. The plastic's cracked. That's no big deal. I can clean this up. The crack, yeah, I mean, if the meter's in that area, it's going to be kind of annoying. But other than that, there's a couple of things about this meter I can tell right away I like, and there's a couple of things that I don't like. And the first thing I don't like is it doesn't have a mirror. Some of your higher end meters will have a mirror. Like your Simpson meters and stuff like that will have mirrors, and that basically prevents, or helps you to alleviate the parallax error looking at the needle at an angle. But this one doesn't have it. But as long as you know that parallax exists, I think you can pretty much look at that and know kind of how to line it up. But one of the things I do like about it is all of the calibration adjustments are right here on the front. So they're easy to get to. You can, I've seen a lot of them where they're on the back or on the side or something like that, or on the back in different places. These are all right here on the front. So that's pretty good. We got some stuff to clean up here. I think I can get this all cleaned up here. This surface stuff here. There's paint on the top. Obviously, I think I can, get most of this off. I may repaint this back plate here. So we'll see. Now, originally this meter, like I said, it's a desktop model, and this is made by Heathkit. So more than likely, we'll see when we open it up. But they made these where they actually built them in the factory and sold them as pre-assembled meters. But then they also sold them as kits, and you could order them and put them together yourself. We'll see if it was put together as a factory meter or somebody put this together. Usually you can pretty much tell if somebody put it together. But originally it would have came with a little gimbal, and that it would have sat in a little gimbal, and where you could change the angle and tighten it down or whatever. And something tells me that they never used the gimbal on this one, because the gimbal would have had the feet on it, and it looks like they put the feet, and this looks like the original kind of feet that would have came on here. Maybe not, but they put them on the bottom, and the way these things are kind of on here, maybe makes me think that this was a kit, but and somebody put this together. But we'll see when we open it up. But yeah, it used to have a gimbal where you could, sit it on your bench, and this thing could turn in different angles or whatever, up and down, so you could see it better from afar or whatever. But it has the actual manual meter movement 0 screw right here. And that's basically, you're going to do this before you do any of the calibration procedures or 0 adjust or anything like that. Another good thing about the Heathkit's stuff is, and I know I'm just going off kind of random tangents here, but I want to kind of get through all this in one video. But Heathkit has got the manuals for these readily available. So I've got the full manual for this IM-5228, and it goes through all the calibration adjustments and everything like that. Unfortunately, this meter did not come with a probe, and this particular model could have came with one of two different probes. It could have came with a probe that had both of the probes would have been a 1/4-inch phone jack, but it could have been two separate probes. One of them would have been for the DC with the 100 mega ohm resistor in series, and the other one would have been for the AC. Or it could have been one probe that had a switch in there that took the 1 meg resistor in and out. But either way, I'm gonna have to build one of those. So that'll be put in the next video. When we go through this, I'll show you how to build a probe for this, and then we'll go through the calibration and the zero and everything, zero adjust and the ohms adjust, and how to do all this and set this up. It's pretty easy, straightforward. But let's open this thing up right now with the screwdriver and see what we got in there. Okay, I'm really hoping that this thing has the tubes and everything in it. But if not, I've got some in my stash, so it shouldn't be that big a deal. But this thing has, I think, I don't know, probably 12 screws holding this thing together. It's kind of ridiculous. There's 3 here on top. We'll turn this around. And it looks like there's 5 here on the back. And I think there's 3 on the bottom. So total of about 11 screws, looks like. And kind of anxious to get this off. The screws look really dirty. So I don't... Now, in the picture on eBay, the light was illuminated on this thing. So he obviously had it plugged in. Which, I mean, you can say that's a good sign or it's a bad sign. I don't know. Maybe he shouldn't have plugged it in, but we'll see what it looks like inside. But the light was working. Oh, there's 6 screws here in the back. So, yeah, there's a total of 12 screws. 6 on the back, 6 on the top, and I believe, or 3 on the top, 6 here on the back, and I believe there's 3 on the bottom. So, all right, we'll grab the bottom ones. Oh, these things are rusted. Oh man. Well, I mean, the good thing is this thing's sealed up pretty good, so I don't think we're going to find any mice or anything inside of it. Hopefully. All right, so last screw, moment of truth. Here we go. I'm going to pull this up. Ooh. Oh, me. Well, we got a lot of cobwebs and looks like insect droppings or remnants. A lot of cobwebs here. Oh, man. This is why you shouldn't fire things up. If you don't open it up and look at it, there could be you don't know what's going to be in here. It could be, shorted across this transformer, or you never know. Oh, me. Man. Okay. Well, it does have, man. It does have, I see, okay, yeah. There's one of the tubes. This is the 12AU7. So this is the tube that's used to be in the balanced bridge. And we're going to go over that on the schematic in the next video, how this works. And then behind this, there's another tube. Let me see if I can pull it out of here. and it is a 6AL5. And what it is basically a dual rectifier. And this is going to be in the circuit that takes your AC measurements and rectifies it to DC, because this meter is basically a DC meter. So we're just going to use DC. So we got to rectify it. So that's this tube, little 9-pin tube, 8-pin tube. Oh, it's a 7-pin tube. This 12AU7 should be a 9-pin tube. Yeah. So little 7-pin tube and a 9-pin. I'll put these on the tube checker and test these out, and I'll have that in the next video as well. So here's something you don't want to see. This thing looks to have the original battery from the 60s. This is probably a late 60s, early 70s kit. It's got the original Ever-Ready battery in it. Oh my goodness, can you believe that? Oh, and it's corroded. Yeah. Look at that. Oh. When's the last time you seen an Ever-Ready battery that looks like that? Huh? Okay, well, so the good news about this is, yeah, I got a little corrosion and stuff in there. But the good news is this meter only uses this cell right here, this 1.5 volt cell, in the ohms setting for resistance readings. This is basically the voltage that it puts across the whatever you're testing, the resistor under test, you know. So I'm actually going to modify this circuit in here to I'll probably take this whole battery holder out, and right here in this area, because there's enough room, it looks like, I'll put a battery eliminator circuit in there with like a, I don't know, I could use a Zener diode regulator, or maybe a LM317 or something like that regulator right here. We can mount it in there, and we can eliminate this battery. We just need a 1.5 volt DC power supply basically, and we can do away with this battery. But yeah, that thing's been in there probably since this thing was built. So let's look at it a little more in depth, and let's see if this was factory made or somebody did this. Okay. Well, all right. So I'm going to say this was a kit, so it's either a kit or somebody came in here later. But I'm going to go with this as a kit because it looks like, yeah. You can see here, there's just, this wouldn't have came from the factory like this. Okay? It just would not have been done like this. And I'm probably going to have to clean this up. But you can see right here, this resistor's flying, way out here, and the solder job on here. This wouldn't have been a factory made. So this was a kit somebody did. You got, it looks like only one piece of heat shrink in the whole thing somebody put right here. So, yeah. Got an electrolytic capacitor here that probably needs changed out. Mica caps are probably good. I'll check all the caps. I'll check all the resistors, everything. It's really important that these resistors and these stacks and these wafer switches, rotary switches are good. Now, from these resistors came as precision resistors. They were probably, at least 1%, maybe 0.5% resistors. And it's really important that they are good, because that's what your measurements are going to be, basically predicated upon, is the value of these. So it's very important that they're close to the value that they should be. So yeah, you can see some of these solder joints in here. Just let me zoom in here a little bit so you can see. You can see some of those solder joints are just not good. So, And Heathkit, when they built these in the factory, you know, did a fairly decent job on them. They weren't amateurish by far. So, all right. So it looks like there's going to be a few things we got to do in the next video, and that's going to be to my camera stand just broke, so I'm gonna have to hold this now. But what we're gonna have to do in the next video, or what I'm gonna do here shortly, and I'll post it in the next video. It just takes me so long to do video edits and uploads and stuff that I just, man, it's just, oh. But anyway, what we'll do is we're definitely going to do the battery eliminator. So I'll show you how to do that. We're going to build a probe, and I'll show you how to do that. You know, you'd think it'd just be any kind of probe, but we're going to make the DC probe. Now, you know, you say, okay, I'm not working with high frequency audio or radio, you know, RF stuff. I'm not working with oscillators or anything like that. Why would I need, you know, a special probe on the DC side and all that stuff? And, you know, really and truly, if you're just working with audio gear, like, you know, audio amplifiers and stuff like that, it probably doesn't really matter. But then what, you know, what do you need a VTVM for anyway? But anyway, the interest I have in this is a lot of the prints and stuff that I get from old radios and stuff like that. They give you the values based off of what a VTVM meter would read on it. So I'm anxious to see how that looks in comparison to a digital multimeter on the same kind of circuit. So I'm going to be comparing that and everything. That'll probably come in a much future video. But I just want to have this thing on the bench and actually use it. Now, you know, even in guitar amplifiers and stuff like that, you may have an oscillator circuit for like your tremolo circuit or something like that. And this could be very useful in that type of application as well, because you don't want to interfere with that oscillator at all. Either change the resonant frequency or stop the oscillator altogether or whatever. And this meter would serve you very well for that. You can stick this on the grid of that oscillator tube and it shouldn't have a problem. But again, I'm going to go into all the technical aspects of this thing. We'll look at the prints and everything in the next segment. I just wanted you guys to see this real quick and see what kind of project we got on our hands here. It looks to be pretty clean on the inside now that I got a lot of those cobwebs up. We can't do any of the calibration and adjustments or anything like that until I get a meter probe built for this thing. So I'll be doing that here shortly, probably today, and I'll document that with the video. But that video may not get uploaded for a while because I want to go through this whole thing, and I may not get to it today. So whenever it gets out, it gets out. But I just wanted you guys to see this. It's the Heathkit IM-5228 vacuum tube voltmeter, 5228 right there. You can see it. Again, some of the features on it I like is the calibration's all on the front here. It's really good. I like the fact that it's only got one input. There are some that would have you know, a separate common, a separate input for the DC, and a separate input for the AC, and they'd actually have two different probes. And then some of them you could use the same probe. The actual 1 meg resistor was internal to the meter, not in the probe itself, which I think you probably want it on the end of the probe. But I mean, some of them would put it right behind the input jack on some models. I think RCA did that and a few others. But these VTVMs, they were made by Elco, you know, RCA, Hewlett Packard. There was a bunch of them that made these things, and most of them were pretty much just like this. They would get you your, you know, your AC, your DC, and then your ohms. There were some higher end ones, like Hewlett Packard made some, and maybe RCA made some higher end ones as well that you could actually do current measurements on. It required a whole nother circuit and everything to do that. They're much larger units and everything, but the majority of these just did voltage, AC, DC volts, and then, you know, resistance. And you have the DC and the positive and the negative, you know, just like in your old analog Simpsons meters, where you could, you know, you could just flip it. If you got your probe on there on the wrong polarity or whatever, you could just flip it and it would flip the polarity inside here. So that's you didn't have to change your probe. So yeah, we'll go through this stack switch. Very hard to turn. So that's going to be a problem getting that cleaned up, and it feels like it's all gummed up. This one's fine. This is only one wafer on this one. This one's got like 3 wafers on it, and I think the shaft is probably gummed up inside there. Yeah, it's moving very, very hard. So we'll get that cleaned up. Got a lot to do here. This pot seems to be fine. This pot seems to be fine. We got 3 pots back behind there. But we'll do that in another video. But I hope you enjoyed this. Stick around for part 2. Should be coming out in the next couple of days. And until next time, thank you for watching.